The topic of our lesson today is generative AI. The AI that can generate, that can create new things. In the context of large language models, it can create a sequence of English words or sequence of words in natural languages. But the generative model can generate more than just English words. It can generate images, it can generate audio, it can also generate software code. At the heart of its ability of creating new things is the predictive ability of AI. AI can predict the next number in a sequence of numbers, the next word in a sequence of words, and this is going to be at the heart of its ability to create or predict a whole bunch of words or an entire document. We're going to start with a quick review of the previous lessons, and we're going to talk about large language model, the AI that can understand and generate human language, and how this ability of understanding and generating English documents can play a role for developers when the AI learns to generate software code. How we can use this ability to generate software code to understand our code, to review our code, to automate some of the tasks we usually do manually, and how the AI can help in more general ways. When you implement your software, you design and implement a specific set of use cases, specific set of functionalities you want your software to handle, and you don't expect the software at some point to learn to handle use cases that you did not explicitly program it to do. So if you want to add more features in the next iteration, you'd implement more features, you'd add more functionality, and you release it. An intelligent program, on the other hand, is software that can learn with time. It can learn and it can improve. At the heart of the intelligence is the ability of the AI to reason about input that it has not seen before. Let's say I wanna design a software that can recognize a character from an image. Every time I draw the image of an A, it's going to be different than the next. So you don't draw your characters in the same way, and if the software is going to be able to recognize the character, then it needs to think different than a regular program. An AI program is one that reasons by identifying patterns. So rather than seeing the A, is going to try to identify the patterns in this input image and see if it matches the patterns of an A or a B or a C, and then it's going to output a score that says how confident the software is that this image is the character A or the character B or the character C. In supervised learning, you train your model on a labeled dataset. Let's take the example of the AI model that knows how to recognize characters from images. I train the model on a set of images, labeled images. Each image has the expected output associated with it. The input is presented to the model, and the model makes a prediction. And then the training consists of adjusting the internal parameters of this function so that in a way that minimizes the error, the distance between the difference between the expected output and the actual output. So basically, I'm finding the parameters of that function, of that map of image pixels into characters or into a number that says that decides of the probability of this image being a character A or a B or a C, so that the error is minimal. Once the model is trained, then when it's presented with new data, and the model is going to identify the patterns in this new data, and is going to try to predict whether this character, this unseen data or new data, is the character A or B or C. A large language model is an AI model that is trained to understand and generate natural languages. You can use a large language model to talk to the program in English sentences. So, for example, you go to Google and you put your query in the way you'd be talking to another human being. I am having issues understanding Java generics. Can you give me some references or some tutorials for beginners how to understand Java generics? And Google is going to understand the query that you've given it in natural language and is going to try to retrieve links from the web that fit the criteria or that match the features of your query. And for the different AI models can be used when it comes to processing natural languages. Recurrent neural networks, for example, are good at processing sequential data, are good at processing data in order, and natural languages have words where the order matters. So these RNNs can be used to perform machine translations, to perform text generations. Another type of AI model that can be used for NLP is the convolutional neural networks that are primarily known for their applications in computer visions, but they can also be used for text classification and sentiment analysis. So these CNNs are good at detecting patterns. So, for example, for image computer vision, for image processing, CNNs are good at detecting patterns, and these can also be used for NLP tests, text classification. The transformer model, which is at the heart of our GPT lesson today. The transformer is another AI model that is good at NLP tasks. The transformer model brought improvement on NLP tasks than the other models because it was aware of the context of the words. One difficulty in analyzing natural languages is that they are ambiguous. If you say an expression in one context, and if you take it out of context, it might mean a completely different thing. It might not mean anything if something is said in a context. So in natural languages, expression means something in a context. And the main, the transformer had the ability of seeing expressions in a context, which gave it a superior ability on the other AI models when it came to processing natural languages. At the heart of the transformer is the attention-based mechanism. The attention-based mechanism is is a way to tell the AI how much focus should be put on other words when it comes to interpreting the meaning of a given word. So the attention was basically a score that decides how much attention or how much focus should the AI put on the other words when it came to interpreting a given word. In other words, this gave the AI the ability of seeing words and expressions in their context. A different so the expression is seen in the context of the surrounding words, which made the AI capable of which made it much more efficient at interpreting human languages. The transformer is an attention-based encoder-decoder. The encoder takes a sequence of input and maps it into a code, into a lower level representation of the code. This code or this compressed information represents the learned information that the model was able to learn from this input sequence. The role of the decoder is to take this compressed code and to try to recreate or to generate an output from this input sequence. The decoder is going to take the input sequence, the current output, and the context of the story, and is going to generate the next word in the sequence story. The attention mechanism gave the transformer the ability of maintaining the context of the story in reference while generating its output. The transformer was able to generate much more coherent stories even when the story was long. The attention mechanism is a means to tell the model how much focus should be put on the other words, or the how much attention should be paid on other words when it comes to interpreting any given word. The attention mechanism gave the transformer the ability of seeing words in a context. So rather than seeing words individually, words were seen in a context. This was at the heart of the ability of the transformer to perform much more efficiently when it came to interpreting natural languages. So while RNNs were also good at generating output sequences, the RNNs suffered from a short-term memory. So it was able to keep context of the story while to be able to generate the next word, but it would become incoherent and it would forget what was the beginning of the story halfway through the story. The transformer with the attention-based mechanism was able to maintain the entire context of the story when it was generating the story, and the story would be coherent, so we wouldn't lose the context of the story because of this mechanism. The attention-based or the transformer also was able to outperform RNNs. So the first thing was seeing things in context and maintaining context of the story while generating. It was also able to perform in parallel, to process its sequences in parallel. The RNN had to process its sequences, its input in sequence. The transformer was able to incorporate the order of the words of the sentence as part of the input information, and by that it was able to process its input in parallel. This gave the transformer the ability to process or to learn on much more information in much shorter period of time, learn these attention mechanisms, these dependencies between the word, to see the words in the different contexts in which they occur, and by that it became very efficient at interpreting and generating human language. It's good to understand that the way this generative model is going to generate the output is going to be based on the training data. At each step, the decoder is going to take the output sequence and the context of the story, and is going to predict the next word based on the probability of it occurring from the training data. The generative model is going to keep predicting the next word in the sequence until it predicts a halt word, or it predicts that this is the end of the story. And when we're going to use ChatGPT, you're going to see that it's generating its output sequence one word at a time. It's giving you a sample of it's recreating an output based on the samples that it was trained on. You provide the generative model with a prompt or some input, and from the context of this input is going to create an output sequence based on the predicting the next word in that sequence based on the data that the model was trained on. So we spoke earlier about the supervised learning and how you label a data set and you present the information to the model, and then you minimize or you maximize the accuracy. In the case of unsupervised learning, you don't have the labels of the data, and by that you cannot reason about the accuracy of the model. But when you train a model in an unsupervised way, the model learns the features and the structure, the natural structure of the data. Let's say I want to train a model to recognize the characters from images, and I have a large data set of characters. The model is going to learn the different patterns from these images without knowing that this is the character A, or this is the character B, or this is the character C. In a famous a famous example of generative model or is the GAN network, where the training consists of training two models, a generator and a discriminator. The role of the discriminator is to be able to, given an input sequence, is going to try to tell you if this is from the actual data set or not. And the generator is going to generate some sequences and are going to be given to the discriminator, and the discriminator is going to try to tell if it's authentic or not. The goal of the training is for the generator to learn to generate samples that become increasingly difficult to discriminator to differentiate from the real data. If the discriminator cannot tell that this is a fake, then it's the discriminator that has to update its parameters. If the discriminator can tell that it's a fake, then it's the generator that has to update its internal parameters. The goal of this training is for the generator to generate samples that cannot be distinguished from real data. So you see, our model is one that generates an output sequence from the sample data that it was trained on. At each step is going to predict the next word based on the probability of it occurring in its sample data, and it's also trained to generate fakes that you cannot distinguish from real data. So even when I go to ChatGPT and I ask it to generate some output, this output is basically a recreation of a document from the data that the model has seen before, and even though it's going to look very realistic, this is not actually a document that was published or that was verified or that was reviewed. For example, if you go to Google and you ask it to give you a link, it will give you the actual link, the actual reference, or the document that was reviewed and that was published in a conference. But the AI or the large language model will give you a summary of that document, will give you an explanation of the document, would transform, translate, or do all these things that large language models can do. But so the idea is it's generated based on the samples that it was trained on, and it was trained to generate things that are indistinguishable from real things, fakes that you cannot tell that they are not real. So this generative learning that we just described, where the generator from some random input is going to generate a sample, and the discriminator is going to try to tell if it's real or not. And if the discriminator cannot tell that it's a fake, then it's the discriminator that has to update itself. And if the discriminator sees clearly that this is a fake, then it's the generator that has to do a better job of generating. This is one way of unsupervised learning, where the model is going to learn from the structure of the data. An example would be the autoencoder, where the AI is gonna take some input and is gonna try to understand the features of that input, and from these features recreate an output that is as close to the input as possible. So this is another form of unsupervised learning, which is not very far from the other one. So GPT, or the generative pre-trained transformer, we explained what's a generative model, we explained what's the transformer, and we also mentioned that this pre-trained, where the model is trained in an unsupervised manner on unlabeled data, the data of the internet, and where the goal is to, in our case, is to see the different dependencies, the different contexts the different words can exist in, so that the model now has seen every word in every context, every expression in every context, so that when I ask it a question, it's going to try to understand it by comparing it to things that it has already seen. Pre-trained models can be fine-tuned, and this would be the regular supervised learning, so that these can be fine-tuned to perform other tasks to be optimized for specific domains. So this GPT is a language model that was developed by OpenAI. Like you say, Google AI is developed by Google. The GPT is developed by OpenAI. You have GPT-3, GPT-4, and recently they're talking about more more versions, the GPT 4.5 or GPT 5. We just explained that the ability of this transformer and its ability to maintain context, to see word in a context, gave the AI the ability to generate coherent story, gave it the ability to understand the input and generate stories that are coherent. The GPT is not the only pre-trained transformer available out there. We just mentioned Google understands natural language also. You can talk to Google in natural languages, and lots of other applications now understand can take instructions in natural languages, and the BERT, for example, or BART are example of transformers that are pre-trained. The GPT is trained on internet data. BERT is trained on books and encyclopedias. So you'd expect the GPT model to be able to, if you talk to BERT and you ask it something that is not in the book or that is not in an encyclopedia, for example, GPT would make sense of your query much better. ChatGPT is an advanced conversational AI model that is designed to generate human-like responses in a chat-based format that is capable of engaging in conversations in human-like fashion. It can understand complex queries and complex prompts, and it gives you this interactive interface to engage with conversations with the model. ChatGPT uses the GPT language model behind the scenes, so it's capable of understanding your prompt, even very complex prompts, and we'll see GPT-4 is much more powerful at understanding complex prompts, or prompts where you want very specific things. You complicate the instructions. GPT-4 is going to be able to make sense of your queries. GPT 3.5 might not be able to make sense of the query all the time. So you go to ChatGPT and you ask it a question, and it generates a response for you. Did ChatGPT do any form of formal verification of the answer? Did it do any form of proving the answer that it gave you? Did anyone review the answer? And we said that this is not true. The ChatGPT is gonna recreate an answer from the different samples that it has out there, predicting the next word in the sequence, predicting the sequence word by word. The next word is predicted based on the samples that the model has seen before, and based on the probability of it being that word from these input data. But what made this GPT more special or more powerful are the things that we mentioned, the attention mechanism and the fact that it was trained on the data of the internet. By that it had seen, it had made sense and was trained on all the knowledge base of the internet, so that when you ask it a question, it's going to try to understand it by comparing it to the data that it has. And we're going to see that this is going to be a very efficient way of interpreting and generating responses. So ChatGPT does not have any form of explicit rules or general or logical rules that decide the language that decide the sequence that's going to be generated. It was not the answer that it's giving were not verified by anyone. There is no formal proof of the correctness of any answer that is given. But as you try ChatGPT, you're going to see that because of the things we mentioned, the AI model was very efficient at understanding and drawing conclusions from the training data that it has seen. So GPT does not have any form of logical reasoning, does not draw logical conclusions from the data, does not prove the things, doesn't understand what it is saying, based the different things that we mentioned that make the model capable when it came to natural language processing. The AI can be, so this GPT can be trained not just on books and encyclopedias, it can be trained on software code, on frameworks, on libraries, and by that it learns to make sense of software code, it learns to generate software code. The Codex is an AI model that was trained on various programming languages. So you give it a program and you ask it to summarize it for you, to explain it for you. You give it a prompt in natural language and you ask it to generate the code for that. And it's very similar in a sense. You give GPT some text and you ask it to transform it or to translate it or to summarize it for you. And Codex was trained on programming languages, so it can reason about programming languages, can do all sorts of things in programming languages. So it can suggest how you want to finish your code, how you want to test your code. It can reason about the correctness of your code. Codex and the GitHub Copilot were not available for free, but you can use any AI-powered software development tool that can help you. You can use ChatGPT itself through the web interface to ask it questions about the code. You'd assume this Codex was trained in a much more rigorous way on software code, so it's going to be able to do a much better job than the regular GPT 3.5 or GPT 4 or ChatGPT. But as of the making of this video, the GitHub Copilot and the Codex were available only for paid subscribers. So we experimented with another AI-powered coding assistant, and we're going to see that it's going to be very helpful in increasing the developer's productivity, in suggesting code snippets that fulfill the desired functionality. So you ask the AI, I want to write a function that removes the duplicates from this list of persons, or that sorts this list of persons, and the AI is going to be more than happy to provide you with a code sample that you're going to have to review for correctness, or that you're going to have to test before you integrate in your code. But as you use these AI models, you're going to learn what they can or they cannot do, what each model is capable of doing and what's not capable of doing. And you're going to see that even when we're saying that this AI is just a glorified tape recorder, it would replay things from the different recordings that it has. But the idea is that it was a powerful the changes that these AI model incorporated recently gave it superior abilities at processing these kind of things. So you're going to see that it's going to be worth the trouble of learning how to use them. So we mentioned that both ChatGPT and Google, you can talk to them in natural languages. So you'd go to Google and you talk to it the way you talk to another human being, the way you talk to your teacher. And Google would be more than happy to provide you with links or references on the internet where the documents match the patterns that the prompt that you provided. So the difference between ChatGPT and Google is that ChatGPT is going to create an answer for you. It's going to summarize the references on the internet and give you a summary that is tailored specifically for your prompt. Is gonna do all sorts of these transformations on the references, whereas Google is gonna just give you the link to the reference on the internet. So the result that Google gives you is basically the published document or the peer-reviewed publication in a conference, whereas ChatGPT is going to do the job of summarizing it for you. And but remember, ChatGPT, so the reference that Google gives you is the actual reference, whereas ChatGPT is going to create something from the samples that it was trained on, and it's going to give you an answer which might not be correct, even though it will look very real. It might be completely fabricated answer that never happened, or that is completely not true, and you should pay attention to that. When you want to talk to the model, the first thing is you need to design a prompt. And when talking to these large language models, your prompt can be a simple sentence like that: please help me translate this text from English to French, or can you please explain to me the concept of Java generics in simple words for me to understand. Or So at the first step in talking to a language model is in designing a prompt. And the idea is to limit these infinite possibilities that this model has seen so that it understands what you want it to do for your specific case. So you want to try to narrow down the infinite possibilities of the samples that the model was trained on to the ones that make sense to you. And the prompt should be as clear and as specific as possible. And we just said that you want the model to look at the data that matches the specificities of your prompt. The idea is you want to provide it with a context that helps make the query more relevant. You can include examples, you can restrict with more instructions, and if you're not satisfied with the answer, you can reiterate and ask it to make some changes to the So when working with these large language models, you experiment with the prompts and see which prompts give you the desired output. For example, if you're trying to make it if you're trying to define a prompt that is very complicated for GPT 3.5, GPT 3.5 will not make sense and will just output something that looks like the answer, so without it being the actual answer. But GPT-4, for example, is going to be much more capable, is going to be able to understand your instructions better, is going to be able to return the desired output or to perform as you're expecting it to do, because it's a much more powerful model and it's capable of understanding more context, and which makes it more accurate. So remember, when dealing with a model, you have to account for the limitations of the model, the biases in its training data. And so even though if you craft the most the best prompt or the perfect prompt, and then the model is not capable of making sense of it, or the training of the model and the biases of the training, so these the prompt will not be able to solve. So you go to OpenAI and you create an account. You can use your Google account, your Microsoft account, or you can create an account with OpenAI, and the account is gonna give you access to ChatGPT, free access to ChatGPT. It's gonna also give you 1 month of free credit to the API. It's going to give you $5 credit to the API, to the OpenAI API calls that you can integrate into your applications through HTTP, REST HTTP. But the credit is going to expire in probably 1 month. The free access to ChatGPT is not going to expire, but there is a cap on how much you can use. Probably so $20 of free usage to ChatGPT, the free version, and the way it's gonna charge is by token. So if you're using GPT 3.5, the way it's going to be charged is how many tokens in input and how many tokens in output, depending on the actual GPT 3.5 model that you are using. Dolly is gonna create, so if you want to work with code, you can use ChatGPT. GPT-4 is much more powerful than GPT 3.5 and is not accessible with the free subscription. So you need to actually promote to a GPT Plus subscription for you to be able to use GPT-4. Now, DALI and the API, you're going to need to have another subscription, in a separate subscription for DALI and a separate subscription for API. So even if you upgrade to ChatGPT to GPT Plus, ChatGPT Plus is not going to give you access to the API or Dolly. It's going to give you access to chat.openai.com, access to GPT-4. It's going to give you access to lots of new features such as extensions or an integrated IDE to write Python code. These will be included in the Plus subscription, but the other AI, Dolly, for example, and to use API, you might need to switch to a paid user. The OpenAI free account gives you access to GPT 3.5. As of the making of this tutorial, GPT-4 is not free, and you need to switch to GPT Plus. ChatGPT Plus is gonna cost you $20 a month. It's gonna give you higher priority even when there is big demand. So these these models use lots of resources, and when the demand is high, if you're a Plus subscriber, you are given priority and your queries will go through. If you're not, then you be denied access to the model. While GPT 3.5 is more than enough for experimenting with the model, for learning what these AI models can and cannot do, GPT-4 is much more powerful. It accounts for more parameters, it understands the context better, and it does much less mistakes. Some of the weaknesses in GPT 3.5 were handled in GPT 4, and it's not going to be for free. You need the Plus subscription. The API and Dolly will not be available for free, and these are paid through a different account. You are initially provided with $5 of free credit for the API, but these will expire, and you need to switch to a paid account if you want to use the API. The payment is going to be based on the usage, and we said is how many tokens of input and how many tokens of output. So to be more accurate, is how many 1,000 is per 1,000 tokens of input and output. And depending on the model, so for example 3.5 is much cheaper than GPT-4. The Dolly, you need to purchase credit, and it would create images from a prompt. Remember the same concept of generating a new image is going to be based on the images that it has. So for example, you can ask DALL-E to generate the image of a lion having coffee with a bison, and it would create that for you. So the main idea before we start using ChatGPT and before we ask it even the first question, went through the concepts behind these generative models and what they what you can trust them to do and what you shouldn't trust them to do. So remember that the ChatGPT, even when it's going to give you a perfectly written document or a perfectly written story that looks like it came from a conference, but remember, this is part of it being trained to do so. So the stories that GPT generate can be completely wrong, completely untruthful. They can be fabricated and fictional that don't relate to that have nothing to do with the truth. So whether it works for a story or it works for a program code or for an image, so you take these with a grain of salt and you need to verify the accuracy and the correctness. So it's your responsibility to make sure that the code you get from ChatGPT or from Codex is code that compiles, that runs, that you've tested, and that you've verified the correctness of. Also remember that these models are constantly learning, and if GPT 3.5 did lots of mistakes, and we're gonna start playing with that soon, but you're gonna see that GPT-4 was able to overcome lots of the weaknesses of GPT 3.5. So as these models learn, at some point you'd assume that these will be able to write code that no one will need to review or test. But as of right now, and with the things we experimented with, you're going to need to make sure that and we're going to start with an example soon to see how the model is going to say something and contradict itself in the next line. This was GPT 3.5. So another thing with GPT is that ChatGPT's training stopped in late 2021. So in September, as of September 2021, all the events that occurred after that, the model doesn't have any knowledge about the fact that happened after that time. But with a Plus subscription, you can install extensions that allow the AI to access the internet. So for example, you'd ask it about current facts, and the AI can access the internet and bring current facts and current events. And this is going to be available with the Plus subscription, not with the free subscription. Also, one thing to understand is that whenever you talk to the AI and you provide it with information, this information is going to be reviewed. If not, it's going to be included in the training, and at some point you go and ask what is Mr. X's password, and the model is going to retrieve. So you do not provide sensitive information to the AI. You do not give it private sensitive information. So the way they say it now is used to that the data, that the conversations are reviewed to ensure compliance, to make sure that you're not teaching the model or not telling the model things that the model shouldn't know. But so the main idea is your sensitive information, your private information might at some point become part of the public knowledge base. Now, unless you want that, you don't want to provide your credit cards or your private sensitive information to the